Good morning, everyone. Let us begin today's first session here. My name is Athur Mabiso. I'm a senior economist at the International Fund for Agricultural Development, IFAD, and I'll be moderating as well as presenting in this session. So I hope I can manage to do both. But I would like to first of all start by allowing different colleagues that are in this panel to essentially introduce themselves. So we have one colleague, two colleagues from WFP, one who's here on my right, Sarah Muir. If you want, you can go ahead.
Hi, everyone. Good morning. My name is Sarah Muir. I'm with WFP's Climate and Earth Observation Unit, and today I'll be presenting on one of our services called Panelist. Thank you.
Great, thanks. And then we have Laure online. Laure, are you there?
Yes, I'm here. Can everyone hear me?
Yes, we can hear you. Please go ahead and introduce yourself briefly.
Okay, hi everyone. Nice to, I'm really happy to be here. I wish I was in person, but I'm working with the World Food Program in the Haiti country office. And so, yeah, I'll be also talking about how we use satellite imagery for crisis contexts. Thanks.
Great, thanks so much, Laure. And on my left, I've got Oliver Mundy, whom I've been working with at IFAD. Go ahead.
Thank you, Athur. My name is Oliver Mundy. I am working at IFAD. I'm a consultant there, working for different parts of the house. I'm trying to make IFAD geospatial, and I work a lot with Athur and introducing guidelines, policies, collecting data, and so on. Thank you.
Great, thanks. So with that, at least now you know who will be presenting to you. So I will go ahead and ask Oliver to begin the IFAD presentation. Just briefly showing what we are doing with respect to M&E, but also impact assessments. I'll take over on the impact assessments part. And then after that, we will ask Sarah to go ahead and present the work that they're doing at WFP, followed by Laure. So Oliver, over to you.
Thank you, Athur. So our presentation, Athur's and my presentation is called Integrating GIS Data and M&E and Impact Assessments, and how IFAD basically does it. Maybe you don't know what IFAD is or which organization. So IFAD is a hybrid between an International Finance Institute and a UN agency. So WFP and FAO basically are sister organizations. IFAD is an International Finance Institute. It's similar to the World Bank, but smaller. And IFAD specializes on agricultural programs. So IFAD finances mainly programs of ministries of finance of various countries. With the aim of supporting smallholder farming, and there's also a strong poverty elevation objective. So it's important to know, IFAD does not implement projects, we finance the projects. We co-develop the projects together with the governments, but the projects are implemented by the governments. So IFAD strategic objectives are to increase production, to increase market access, to increase resiliency, and to promote greater economic mobility. Here you can see all the figures. And so this presentation is specifically on M&E and how GIS is used, or how we are using, and we want to use GIS in M&E. And the best way we thought to present this is by an example. Here is a project in Rwanda, the Kiherere Community-Based Watershed Management Project. It's an old project. It's completed in 2016. And in the final year of the project, they mapped everything what they did. So you can see here on this picture, they mapped the roads. So this project developed feeder roads. You can see maybe the terracing that they did. Had water user unions. They did drying grounds. They distributed cattle. They had all sorts of local institutions they developed. They developed irrigated fields, they built dams. And so all these investments have a spatial dimension. And what we want to do is to map these things. Currently, most IFIs don't have requirements for georeferencing. Many of them are now working on such requirements. And we want to reduce these requirements. Once we have this data, well, I'll get to that later. Another example from Sri Lanka here is this project's closing this year. They developed smallholder tea plots. So basically, for rubber plots, here you see rubber plots, for example, and they mapped all the rubber plots, about 4,000 of them. And once we have this data, we can do interesting analysis with them. We can see, literally, we can watch the trees grow. So this type of investment is quite simple to monitor. Others is a bit more complicated, and this is where we need colleagues who have more experience with this and remote sensing experts. Another nice example is Capo Verde. It's POSER, the Rural Socioeconomic Opportunities Program, which is also closing this year. They will be extended. And they mapped all the investments that they did, and they also put it in a web dashboard. You can visit the dashboard there, and you can literally visit every single investment. You can see cow sheds, you see photovoltaic installations, you can see water tanks and so on. So that's quite nice. So these are so this data is interesting for the projects, but it's also interesting for us for IFAD who finances these projects, and this data can be used for multiple purposes. First of all, to measure the achievements of targets. So if a project says, oh, we're going to build 100 kilometers of road, you need the polyline to measure the exact length. We need to know when it was built. In the attribute table, we need to record what was exactly done, a drainage system, did the surface, was it upgraded, and so on. This data is also used for supervision. So once per year, a IFAD team, at least once per year, visits the project and sees the investments. So with this data, they can plan what they want to see. Safeguards is also a big topic for international finance institutes. Of course, the project wants to do good, but there's also a risk of that they could do harm. And so with the GIS data, we can screen for potential risks that could happen. So let's say if the project is intervening in a national park, or then audits. Our auditors are also interested in this data. Procurement, that's the new big thing to get GIS data. Might be a bit surprising. Then monitoring fragile states, so like Yemen, Iraq, Afghanistan, Niger. That's where we need these types. I think also our colleagues in WFP will tell us later more about such systems. And then, of course, then Athur comes in at the end and wants to measure the impact of these investments. So now we know where the plots are, and that's the basis then for what is actually the impact? How did it contribute to poverty reduction? How did it help increase farmer incomes and so on? Athur and I, we did inventory three years back. We tried to get as much data as possible from the portfolio. We found out like all projects collect some sort of data, but there are no standards. There are various degrees of quality. Our IT colleagues call the data spaghetti data. It's like a bit messy. And yes, and it's only used for planning and monitoring, so no advanced assessment, so no impact analysis. So we published some guidelines. You can find this online, basically suggesting requirements, standards, terms of reference, checklists, and so on. It's now available in English and French. So this is not rocket science. It's basic georeferencing of projects. Yes. So that's what we are trying to introduce. But changing organization is how do you say it takes time. And so we've been working on influencing policies and guidelines. So in IFAD's data governance policy, we've introduced GIS as entry points, the safeguards as well. So all risky investments have to be mapped in the IC, so information and communication technology strategy and action plan, the M&E action plan, targeting policy, all their entry points. And now we're currently working on, we haven't done it yet, but we want to work on specifically on how to get the data from the projects. Procurement is going to be the new big thing. Most of the projects, all the big stuff, projects have to procure. That means it's done by a service provider. So all the works, all the engineering companies and so on. So here we want to specify requirements that they have to deliver the data through the procurement system that IFAD is currently, the new procurement system. So we hope that we're going to be swamped with data in 2 years' time. And that will be a big game changer. We want to increase GIS literacy. So we don't want people to become GIS experts. But we want them to read a shapefile so they can, so we don't have to make maps the whole time, but they can just look at the data, zoom in, look at the attribute table, see, this was done there and there. And then for advanced analysis, At the moment, we have got 1 or 2 remote sensing experts, and so IFAD's capacity is pretty low. So we need agencies like WFP, FAO, the European Space Agency, in order to when we have the data, then to really analyze it. So that's from my side, Athur. Over to you. When I have this.
Hi, before
Oliver, so that's the M&E part. In fact, we always say monitoring and evaluation. And it's interesting because for us, our impact assessments are actually, in effect, the evaluation part of M&E. And without the monitoring data, it's essentially impossible for us to do our impact assessments. Why? Because first of all, we need to verify where these interventions happened. Did they actually happen? Because we can't just go in there and do impact evaluation if nothing was actually done. So the basis of all this is the M&E data that Oliver has presented. But we have a methodology or a practice, as we call it at IFAD, in terms of impact assessment, which is a commitment to our member states to report on our impact based on a rigorous methodology. So what we do, we sample 15% of our projects across the world that are closing in each 3-year cycle, which we call the replenishment cycle. And basically from that set of sample, the random sample of projects, we then undertake household surveys, as well as community level surveys, in addition to complementing with the GIS data. And so after having done each impact assessment, we then bring all these estimates together and then do a meta-analysis and then project to the whole portfolio to get a sense of what is our impact at the corporate level. So this is just to give you an understanding of why we're doing the impact assessments, how we're doing it. In terms of specific sort of steps, the basic approach, as I indicated, we basically look at the portfolio, sample 15%, and then we do impact assessments in each country, in each project, meta-analysis, and then project to estimate the actual numbers of people that are impacted. So the numbers you saw earlier actually are derived from the impact assessment. Those were the targets, but we actually can measure what we actually achieved relative to the targets. And so this is just one example of the results where, based on the meta-analysis, you can actually also look at different projects across the world, different countries, and actually see where we're doing well, where we're not doing so well. So it's really keeping ourselves honest and being transparent and saying, okay, we may have impacts in certain areas. So on average, 23% higher income for our beneficiaries. But in some countries, we're actually not doing very well. And so it also helps us to go back and redesign and think about how we better design our projects in the future. In terms of our approach, we really try to use an approach that allows us to get at attribution rather than contribution. So of course, ideally, you would want to see the same beneficiaries in 2 states with and without the project, but that's not feasible. So we then have to create a counterfactual or control group. And this is done using geospatial data. This is just a picture of the different projects that we've actually done an impact assessment on across the world for the previous cycle, 3-year cycle. And we actually have one ongoing at the moment for the follow-up cycle. This here gives you a bit of an overview of different parts of our workflow where we actually integrate GIS. So as I indicated, from a counterfactual design perspective and identification strategy in terms of our impact assessments, and then also with respect to data collection, this is usually useful for us in terms of data quality assurance, monitoring that the enumerators actually go there because they have to geotag each survey that they do. And also with respect to measurement, improving our precision in terms of measurement, particularly with respect to things like land area estimates, for example, or the length of roads, as well as measuring climate shocks. So one of the key issues that we are looking at is climate resiliency. And to actually get at that in terms of exposure to shocks, we use GIS data or remote sensing data. And then, of course, in our estimations, whether it is in terms of the matching, which is our traditional workhorse in terms of identification strategy, is our treatment effects models. But in cases where the data allows, where we have baseline data or panel data, we then can also leverage more precise or more rigorous methods to estimate the impact. And then one aspect which we are really interested in looking at, and we'll start looking at in terms of some of the older projects. You saw the one from Rwanda closed in 2016. We look at sustainability of impacts. So even though the project closed in 2016, do we still see impacts today? So this is one of the things that we really want to look at. especially when it comes to some of the climate and environmental impacts, did our projects really build resilience in the long term? So the basis of this, how do we do this? Well, mostly it is really basic georeferencing. We need to geotag our investments. And this is an example here in the Philippines, and I'll really delve into this particular project because it's one that I really worked on, which I thought was really interesting because we did this during COVID-19, which showed also the value of GIS in context when you can't travel. And what happened was that the project team was able to georeference the houses, also the farms where they found the crops. And based on this, we're then able to have a nice sampling frame, which allowed us to then sample and get also a way of actually achieving a counterfactual. Another example is from Papua New Guinea, looking at coffee and cocoa farmers. In this case, this was an investment where we put in roads and essentially based on also support from the European Space Agency and the data that they supported us with, being able to actually find really good control areas that had similar road infrastructure and accessibility conditions at baseline to then generate our counterfactual. And in this particular case, we also tested the use of machine learning approaches, this basic random forest prediction approaches. In Vietnam, looking at a different issue, which is salinity or saline intrusion in terms of the sea level rise affecting the nutrients of the soil, making it difficult to grow rice. And in this particular project, what the project did was to also install sensors to actually measure the level of salinity. And so what would happen is essentially when salinity rises, then the farmers can open the water gates to allow the irrigation water to go in and help reduce the salinity. And what we were able to do in this case is also leverage administrative data from the government, where they did have pretty interesting data which monitored the levels of salinity. So again, in a sense, this is a climate shock, but also being able to then measure whether our project, which intended to address this in terms of climate adaptation, whether it actually achieved this goal. Another new approach which we're testing, this is relatively new for us, is actually assessing whether our projects have any impact on conflict. And this is a particular case in Mali where we knew that there were conflicts between pastoralists and farmers who cultivate crops. And then being able to use geospatial data and essentially defining our control group through a synthetic control approach to then estimate the impacts of our investments on conflict outcomes. I'll quickly skip this, but essentially we do find that our projects are essentially at least buffering the onset of conflict. So in a sense, preventing conflicts from happening when you compare treated versus control, which is good news for us to know that we can actually also have impacts on these other indicators that we don't normally monitor. This is a particular case in Bangladesh where we use, again, geospatial data looking at road infrastructure. This was the coastal climate resilient infrastructure project. So essentially trying to improve roads so that when floods come in, these roads are still in good shape and farmers can still access markets. So being able to look at these roads and then also looking at markets where we invested in the infrastructure of the marketplaces to actually make sure that agricultural marketing activities continue despite when flood seasons come. And in this case, again, we were able to identify a counterfactual through geospatial approaches to then estimate the impacts of the project. Now, I will go quickly into this particular case. I will run through some of the slides. We have a paper that is forthcoming where we have used geospatial approaches to first design our counterfactual, essentially first come up with a sampling frame for our control group, and then randomly sample and then actually go and do interviews. And this was done during COVID-19, so particularly interesting given that travel was quite difficult, but still able to actually conduct an impact assessment in that context. And so essentially what we were able to do using OpenStreetMap and Google Earth Pro is look at the sites where we essentially had defined villages that were adjacent to our treated villages, but did not receive the project. And then looking at all the buildings in those villages and essentially assuming that these are houses, so these are potentially households. And so after geotagging all of these, we then randomly sample 20 in each village. And then our enumerators go into the field, go there and verify through a screening questionnaire before they actually start the interviews. And that screening questionnaire was based on the selection criteria used to select the treated households. And what we found in this case is really relatively good match. So when you look at the geospatial variables, in general, similar numbers, sometimes different, which is something that we realized that in some cases you will have differences. For example, at the bottom there, you see that population density is quite different between our treated areas and control areas. But of course, it's a parallel trend, so hopefully that helps. And the beauty is we can also still control for this since we have the geospatial data. This is geospatial data from World Pop in terms of population density. And on the left, you have the locations where we actually did the surveys just to get a sense of the distribution between treatment and control. And then just quickly on some of the results that we find. So the project was focused on trying to commercialize these remotely located farmers. And we do find actually that the project did achieve some of these impacts, particularly on high value crops. If you look at the results for horticulture in particular, really strong impacts, also a little bit on export-oriented crops, particularly coffee. However, no impacts on grains, which was in line with the theory of change because the project did focus on commercialization. And then another aspect which we found is that there's more diversification of crop production, which hopefully could also help with resilience of the farmers. And as I indicated, barely any impacts on actual rice yields or rice production, but non-rice crops are positive impact. I think one of the key lessons for us from this study was that you are also able to differentiate and see which geographic areas are really having an impact versus where you might not be performing well. In this case, one of the lessons we learned from this is actually that most of our impacts are coming from farmers that are closely located to the road infrastructure that we constructed. So in terms of meeting our goal of leaving no one behind, we do need to do more and do better in terms of how we design the projects to include those who are actually remotely located. With that, I will close. I think the general points here is that GIS is really useful for us. It's a complement to our survey, allows us to measure so many things. And also with the new advances in computation and analysis, we look forward to exploring other methods and approaches. And thank you so much. That's all from our side. Thank you. I think I'll pass it on to Sarah at this point, if you can.
Before we proceed, I just wanted to reiterate that these sessions are recorded and your presence here does acknowledge that we will be recording and the use of photography.
Hi again, good morning. Excuse me, I have a cough this morning, so I might have to just step back and yeah, so apologies. So thank you all for joining. Today I'm going to be presenting to you WFP's Asset Impact Monitoring from Space Service. Before I go into aims, I'll just go ahead in one slide. Excuse me. So the Asset Impact Monitoring from Space Service actually resides within the Research Assessment and Monitoring Division at WFP, and specifically the Climate and Earth Observation Unit. We are approximately 20 Earth observation scientists, data scientists, and we are leveraging Earth observation data to support WFP operations. And AIMS itself, specifically, we are a resilience monitoring tool, and we are an all-women-led team within our unit. So what is AIMS? So AIMS, it is one of WFP's resilience and monitoring tools, as I already mentioned, and we are leveraging very high resolution satellite imagery and also landscape monitoring techniques. At the surface, it really came from humble beginnings. Back in 2017, we were part of an innovation accelerator program within WFP, and we just did a couple of ad hoc projects to see if we could use satellite imagery to monitor program development projects from space. So this pilot project, over the years, we have transformed it into an operational service with the objective to generate evidence of WFP's interventions on the landscape and demonstrating how WFP is changing lives and regenerating ecosystems. So there are many uses of AIMS within the organization. And although we are specifically focusing on support to our program colleagues in asset creation, there are, of course, many other applications that this could be used for, also in engineering. But we are also supporting our evaluation colleagues performing some ad hoc analysis to support inputs to their evaluation reports. And the AIMS reports can also be included in the country strategic plan evaluations as well. We all know here that satellite imagery is very visually compelling, so it's a great tool for advocacy. So we routinely use our outputs in advocacy material to demonstrate how the program or the project is performing. And then in terms of reporting, in the last year, we have developed 2 corporate indicators to be included in our corporate results framework. So it's the first indicators within WFP that are completely derived from Earth observation data. And this means that those country offices that do subscribe to the monitoring, it's mandatory that they include these indicators in their annual country reports, and we also include them in our APRs too. So to give you an idea of our spatial or geographic coverage, since the beginning, or since around 2018, when we began to become operational, we have supported across all of the 6 WFP regional bureaus and have supported a total of 26 country offices. We're at actually, I think, maybe 3,500 unique projects this year that we are monitoring remotely. And this figure on the images is actually not up to date because we've analyzed so many that we stopped counting. That includes the visual interpretation of VHR imagery, but also our time series analysis as well. And that's why it's such a high number there. So in terms of advantages to AIMS, so it offers a systematic and rapid check of asset presence. I guess I should actually let you know what an asset is. I'm talking about asset impact monitoring, but the projects I'm referring to is anything that can be detected in satellite imagery. So it could be a water pond, we could be looking at a reforestation initiative, a dam, feeder roads, etc. So by using and leveraging satellite imagery, we can really do more routine and rapid checks of these areas. Of course, WFP, we have a large field presence, and we are able to go out and check some of these projects, but in some cases that is not possible. So to have this remote check is an advantage. And also there are projects that we are no longer monitoring. So we have this sustainability. We're able to look back in time to see when the project was implemented. WFP moves out of the area, and we can still go today and confirm that it's being used and that the asset is being used. It provides an objective and quantifiable information over large areas with reduced financial resources. So there are, of course, some costs behind running the service, but compared to having a field mission where you have to have cars, pay gas fees, and pay the hourly rate of employees to go out and check the site, we can do it for a lower cost with satellite imagery. And of course, the advantage of monitoring over highly insecure areas where WFP no longer has access. And then, as we all know, we're familiar that using Earth observation data, we're able to detect those biophysical variables that are not visible to the human eye, such as plant health, etc. And over the past couple of years, while growing and developing our service, we have invested significantly in the infrastructure behind it, so that the database where we're storing all of our geographic information, our observations with analysts, and storage of all of these imagery that we're using. So it means it's a scalable service. When we began in 2017, it was just these ad hoc projects, but now we're really able to ramp up and support those country offices that are interested. There are a total of 3 work streams within the AIM service. The first is asset detection. The second is the landscape impact assessment. And the third is site prioritization, which is our newest and still very much in its infancy. And I'll talk about that at the end, although in the process, it kind of starts at the beginning. So asset detection, what do we mean by this? Well, we are using very high resolution satellite imagery, so less than 1 meter resolution to visually identify the asset within the image. So it's just a visual check and a visual piece of evidence to say, yes, it's been implemented, and then we monitor this through time. Out of this, we have one of our corporate indicators. We call it the ADI score, the asset detection indicator. This is simply the proportion of those assets submitted to AIM's monitoring that we are able to identify, and this is included in the corporate reporting by the country offices. There are a couple of different ways that we can present this. Yes, the imagery is very visually compelling, but we have managed to also bring it down just to a number for executive summaries, but for high-level managers that are just interested in seeing the figures as well. So there we go. And then there are a couple of different categories that we use in standard, and that's visible, not visible, maintained, and no imagery. So I think they're self-explanatory. However, the not visible asset category, in my opinion, is actually the most valuable to WFP because it's a check to see how well we're doing. If we're unable to identify those assets, it sets a priority for the country officers to go and check and understand, why can't we see it? Is it a limitation in our analysis on the AIM side, or perhaps there is some other reason why it was not implemented? Or in some cases, we have the incorrect coordinates, which comes back to the data collection, which still tends to be a challenge, but we are improving as time goes on. So the second work stream is the landscape impact assessment. And this leverages time series satellite data. Typically, we are using Sentinel, Landsat. For large areas, we have used MODIS as well. This really allows us to look at the intervention start date, and then we're able to look back in time and understand, well, what's the seasonal patterns? What are the vegetation patterns before the intervention takes place compared to when the intervention happened, and how it looks as we monitor it going on. Through this work stream, we have our second indicator. It's called the Landscape Contrast Indicator, and we recently just published a paper in the ISPRS, I believe. It should be coming out in the next couple of weeks over our indicator. So that just adds some credibility behind some of the work that we're doing as well. So as you can see here, we have 3 images. This is a site in Zimbabwe. And we can see back in 2011, within those polygons there, it's basically homogeneous green. There's not too much going on. And as we proceed through time, we can see some changes there. And those changes we're able to interpret and understand that it's been transformed from a rainfed system to an irrigated system. And as we look at we have a control site and the intervention site. The intervention site is this green line here, and the control site is blue. After the intervention, we now have 2 cropping cycles. So we have evidence that, well, firstly, visually, it's been implemented and it's functioning as it should. So to go on a little bit into the landscape contrast indicator, so in the same way that the other indicator that I explained, it's a proportion of the total assets that are submitted to us that we have found to have improved vegetation or soil conditions. And I'll just go into a couple of details about the methodology. So of course, we have the project data collection through the country office. We require that they provide us with polygons, not just XY coordinates, because we then extract the time series data from that polygon site. I'll just go back one step. And then within our unit, the Climate and Earth Observation Unit, we are quite fortunate that we have lots of infrastructure to process large volumes of satellite imagery and filter it, smooth it, remove atmospheric interference, etc. So when we're starting our analysis for this indicator, we have as clean a data set as possible. We then go on to the next step, which is the k-means clustering. So this example up here, the polygon in the center, this is our intervention area, and the polygon around it is our control site. We run something called k-means clustering to identify those land covers that are most similar, and then we mask out those that are significantly different from our intervention site, because we don't really want to be comparing a water body to an irrigation field to a forest, because we're going to have skewed results. So we apply this k-means clustering. Then in terms of the control site, this is an area that we know that there isn't a WFP intervention, and we buffer the zone around the intervention area. And why do we do this? We want to ensure that it has the most similar conditions in terms of weather, rainfall patterns, distribution, and temperature. So this is how we allocate our control site. So we're comparing the intervention site against the control site. Then the output for each of these sites is a chart. And we're able to see this red dashed line is the intervention period. And then we can see the pre and post value comparison. So the top chart, it doesn't look that compelling. There's a slight increase, but we actually don't consider that as an improvement as being significant. So there's a 10% threshold above or below if we consider it improved or deteriorated. But the one in the bottom, you can see there definitely is a significant improvement from the intervention site compared to the control site. So for each asset, then we assign whether it's change or no change. And then all of those sites that we have found to be improved go into our landscape contrast indicator. Okay, I mentioned this before. I won't go into too many details regarding our development, but we have a new smart database, let's say, that's in the final stages of development. One of the many challenges, and I know that IFAD experiences it too, is the data collection and putting it all in one place where it's accessible to then conduct additional analysis, whether it's for AIMS or whether it's for other people within the organization. It's not entirely systematic at this point. So we have this data bridges smart database that brings it all together and does validation checks based on the location, but also the asset category and some of the additional information from the country offices that describe the asset that makes it possible for us to interpret what we're seeing. So that's in the final stages of development and should be released in the next weeks. We have invested in the automation of our workflows. So previously we had lots of piecemeal scripts here and there to do different parts of the analysis, but we have combined it all together to have one consistent workflow that we have our LCI analysis and the output is a chart and the indicator result. I would say that this still is expert guided. At certain points, we do have to step in and just ensure that that it's making sense, especially for our interpretation for the report, but it's fully automated. We are integrating additional high-resolution data sets where possible, and also including temperature and soil indicators. We've had a recent pilot with a company called Soil Watch. So we're looking at their soil related indicators from remote sensing data, and we are bringing it into the AIMS workflow. So previously, as many of us have done, we have relied heavily on NDVI to fuel AIMS and to get our results, but we don't see the whole picture. So it's necessary that we bring in these different data sets. So the last point is site prioritization. This is our latest work stream, and it's still in its infancy. And we will be running pilots this year and next year. The first pilot to be run in our Zimbabwe country office. So the intention of this is to harness some of the remote sensing data products and maps that we already produce within our unit, within the service, to provide to our partners and to our WFP program colleagues before they select the site for an intervention. So it could be on the soil quality, the soil type. We might look at a digital elevation model. It really depends on what type of intervention will be taking place. And this comes into our, we call it it's a 3PA process in a community-based participatory planning stage. So they are output maps that go to the community leaders, and it helps inform them of additional information they might not have, or perhaps is validating what they already know about their community as well. So this is, you know, like I mentioned, still in its infancy, but will be part of one of the main work stream. So that's it for my presentation. Thank you all so much for listening. And if you have any questions, feel free.
Thanks so much, Sarah. I think we can maybe let Laura present, and then we can open up for questions afterwards, if that's okay. Laura, the floor is yours. I think your slides are coming up pretty quickly, pretty soon.
Let me know when you can see it.
Yeah, please go ahead.
Is it okay?
Yes, we can see it.
Great. So I'm gonna explain a bit how we've used also. So I'm also working for WFP, but kind of focusing on how satellite imagery applies to how to reach areas and how detecting cropland abandonment can help inform WFP's response. And I'm going to take some examples from results we conducted in the Sahel, and also then applying to Haiti. So just trying to give a bit of context, how insecurity and food insecurity can relate. So basically, this example is a bit old, but it's just because it's the basis of the, like the start of the kind of research on the fly analysis that we conducted when I started being based in Mali in 2019. And the security crisis really started to be an issue in specific areas of the country, in the center, in Mopti, for those who know a bit Mali. And the security situation really hampered the monitoring of agricultural product and of the national food security analysis, because areas like those areas could not be reached due to access constraints or high risk related to field missions. So I'll take some examples of where we conducted and developed the methodology. First in the Sahel, and then like how it's applying to other country offices actually, and how the methodology has evolved too. So for this, we developed an analysis of interannual cropland change based on Sentinel-2 imagery. So I'm not sure about the audience, how much I should go into detail into what's Sentinel-2, etc. So I have prepared a few slides where I can go a bit more in detail. But basically, what it does is the idea is to really help evaluate what. Yep. Okay. Yeah, trying to evaluate the impact of conflicts on agriculture and so on food security in those areas where there's very few to little to no information, and then to better plan the emergency response. So in this example, on the left, there's this is an image, the Sentinel-2 image, single date over a few countries, like the little stars are showing villages, right? So in the center of Mali, where you see the rectangles all around that are agricultural fields that are visible and observable on the imagery. And 2 years later, after a lot of insecurity has expanded in the region and a lot of inter-ethnical community conflict has arisen between, so you can see the kind of blockers in the villages where people started to just cultivate in very condensed areas next to the villages and like 1 to 2 kilometers away from the villages only because of insecurity. Right, so this is just to kind of give some quick visualization. Now, if we go a bit more in detail, the data and the tools that are being used. So Sentinel-2, as I explained, for those who might not know about it, or like to have a bit more details, they're provided by ESA Copernicus, the program by the European Commission. And this imagery combines very good and very adequate characteristics to detect agricultural fields over the specific areas of interest, because that's one of the big challenge there was and there is still in the Sahel, is that the type of agriculture is very changing. It's not like if you look, I don't know, in Syria, where it's like maybe more it's easier to detect, maybe because of the type of landscape, because of also the timings, and it's like unmechanized also in the Sahel, and it's very challenging to automatically detect agricultural land or to use the existing land cover, land use products. So there was really this challenge, and then also by using Google Earth Engine that probably people have heard of, and it's this platform online. It's like cloud computing, and you can do all the analysis using this platform, and that's what this methodology has been based on. So that's it for the tools, and there's a little of there are 6 how do you say, like items, let's say, of advantages for this, of why the Sentinel-2 imagery. So I will share the slides, but like it to go very fast, it's just that, you know, it can, it's a global coverage, so it can cover like very, very large areas. Just to give a number, in 2021, the analyzed area in the Sahel was above 1.5 million square kilometers. So this is just to say, when you compare to, if you have to gather the data, even if you had access, that would be hell of a complicated data analysis. But with satellite imagery, everything is kind of made like, not, I wouldn't say possible, but easier and feasible in a sense. And so the fact that it's available in those areas, obviously, and the possibility to go back in time, because this mission was launched in 2016. Excuse me. So that means that you can actually also go back in time and compare the current situation with a pre-crisis situation. The fact that it's also updated every 5 to 6 days, and it's free. I mean, it's like, I don't know if I can say it's free, but it's openly accessible for now. So yeah, that's now what I'm gonna go a bit more into the methodology, like the type of product that is derived from the Sentinel-2 imagery. So the idea was really to extract the information contained into the Sentinel-2 imagery, not just one image, but all the imagery available from the beginning to the end of the agricultural season. So because it's acquired every 6 days, we looked into the period that's 15th of June, 15th of October, because it approximately covers the, theoretically, covers the agricultural season in that area of in that part of the world. So yeah, we used it to kind of highlight the croplands, or the, you know, it also makes very clearly appear the villages, like everything that's constricted. So to make it a bit more visual, on this slide on the left, you have a single source image. It's what you can see on Google Earth for this area in Mali, central Mali. So you can guess that this may be a village, and you do see there are some rectangles and but it's quite hard to say. And like, you don't even usually know when this image was acquired, right? Or you can go and look into it. But the idea was really to create a composite image. So called time scan, because it kind of scan timely information. And it creates, it's a higher level product derived from all this. So it's like 20 images, I would say, something like this. And it is the same area, but on the time scan image in the center, you do see what the same example I used earlier, but you do see in black the village surrounded with cropland that really singles out from natural vegetation that is much lighter, I would say. It's a different color, right? Then I will go a bit more in the next slide what these colors, where they come from. But we were able in 2019 to go and do some validation from the field in that area, where we could not do this today, I guess, because it was really before it became not just hard to reach, but really inaccessible. So we managed to validate the results from satellite images and go in the villages that were affected, where you could see that, you know, like the fields got concentrated much closer, and so there was a massive cropland loss, right, seen from satellite imagery. And indeed, in all the villages that we went, and we could very clearly see that delineation between the harvested field in the left. So that was November, was the end of the agricultural season, and then on the right you do see the uncultivated land, and it was kind of imposed by armed groups and militias, and people would not be allowed to cultivate for like safety reasons. So now this is a bit more just a slide to quickly show what this 3-period time scan is. So it's a red, green, blue composite based on NDVI values, right? So as I said, it's always going all along the agricultural season, and it's really, the idea is to use this as for visual interpretation. And so I'm still like showing the same example of this village, but basically what you have to understand is that each pixel corresponds to 3 values, and it's a mix of red, green, blue, right? And the red corresponds to the max value of NDVI in the beginning of the season, and then green is for the middle value, like the value in the middle of the season, and blue is for the end of the season. So the idea behind this is that the evolution of values, of NDVI values, are different if you're looking at croplands, where, you know, like the land is prepared and then it grows and then it's harvested. While if you look at urban, not urban, but built up areas, then it should be, that's why it's black actually, because the values are 0 all along. And natural vegetation is going to have a different curve, etc. So yeah, it also really depends on each context, right? Because for instance, in Mali, there's a single rainy season, might not be the case in other countries. So this is important to take into account the timings that work best to single out cropland. Oh, and there's there's more detail. There's a paper that you can go and look into it if there's more interest. Right, so now this is really like how it looks before and after. So we first looked into like 15 villages because there was this black box kind of area with no information whatsoever. And we looked into 2018 compared to 2019 with that product that I just explained, the time scan. And for each village, there was this like massive like cropland abandonment that was visible. And so it really provided some information that indeed like people like do cultivate. Like it's not just that people stopped cultivating. It's actually the village got destroyed. Like you can see, I mean, destroyed, it's abandoned, it's been attacked. People, there was a lot of displacement. So all these images, they can provide a lot of information. They're just about agriculture, but also about like the security in areas with very limited data available, right? So on the right, 2019, I don't know if it's clear for it's the first time that you see this this type of products. It might not be, but basically all the dark, like dark blue and purple squares, rectangles on the left around the village, surrounded by this river. Then on the 2019, you don't see any of it. But still, you can see on the right, like there are some areas where people like could still access to their lands and cultivate. So all this really provide a lot of information. And when you combine and connect with the information that, people like from the National Institute of Agricultural Statistics or like Ministry of Agriculture and what they have from the information in the ground, and this really becomes an interesting product. Okay, so then from this, so this was an example of one locality, and then from this product, we derived a map at a regional level. So this is for Mopti, Central Mali. So it's because then after seeing that for this those 15 villages, it was interesting, the information we could get, we kind of, okay, now we have to get an overview. And what does it look like? So this was really helpful and useful for us to kind of, okay, to understand the areas that were most affected. And we thought that also combining with the, and that's the chance we have with satellite imagery and GIS stuff, is that there's a lot of data available out there, and most of them are just, you can just grab it, and it's the case with ACLED. And so we overlaid with violent events layer for that specific period of time. And so by combining the two, you can see, so in these brown circles that you can see on the map are violent events, and how it correlates with cropland loss. So the red dots are the villages, the localities where important. So it's like above 50%. It's kind of a threshold that we set of the croplands surrounding the locality disappeared from one year to the next. So it's 2019 compared to the previous year. And then orange is medium, and then like yellow. Hope it makes sense, but basically that highlights areas that were more impacted. And then because there was this an interest to, because also in security spread it out in that region very quickly. So 2020 there was a will to actually extend and scale up this product and this analysis to all areas that were considered as hard to reach or where there was an interest. So some areas like the northern kind of Mali, Gao, and etc. There's not much agriculture, so it doesn't make too much sense. But along the river, that it was worth a try, and we did actually highlight areas with massive cropland abandonments, and especially as you can see in like northern Burkina Faso and still like the Mopti area, also in northwest Nigeria. We also tried in Chad and Central African Republic, Nozo in Cameroon. So yeah, that was a try, and it's still now being like analyzed, because there's been a lot of capacity strengthening activities around this too. And just trying to show is the little zoom in. I think that's quite interesting in some areas where this kind of analysis really showed also, okay, it shows the cropland loss, cropland gain, but it does say a story. Because in that case, you do see that all the abandonments, the cropland abandonments, are on the southern eastern part of the Route Nationale. It's the national road in Difa area in Niger. That was actually very unsafe. Like the levels of insecurity were really high, and that actually showed how people got like displaced or moved from that unsafe area to safer areas on the other side of the road. And that's where you see also lots of localities have show some increase in agricultural lands. And if you look at this, like 2021, 2022, even today, like this is like expanding even more, and it does provide this type of information. Okay, now I'm gonna just show quickly how this has been taken kind of to a next level in Haiti, because trying to now not only show which localities have been affected, but also how much they've been affected. So in this case, we've tried to extract the surface areas of cropland losses and cropland gains. So this is in one department in Haiti called Artibonite. And this is the main plain, the main rice plain of the country, where most of the agricultural production comes from, right? And so this shows in red the actual field areas where there was a decrease, and then in blue where there was an increase. So it's also showing how from one side of the road to the other, it shows areas where people like basically moved out. And it's interesting because we also overlaid with the information we had for insecurity. So also not just ACLED you can see in like the brown circles still, but also, you know, you see this triangle between the three cities. This is where gangs violence have expanded, and like the influence has become since 2022 especially, but since actually 2018 is when the crisis in Haiti has restarted socially, economically, and also like security wise. So yeah, this is it. So we've tried to estimate the number of hectares and stuff. This is the same product, but comparing, not comparing today with the start of the crisis, but today with last year, right? So it's also, it then requires a lot of, you know, combining with the existing information and stuff. But okay, and this is how it looks when it's kind of zoomed in, and the NDVI difference calculated from Sentinel to imagery, just kind of really highlighting fields that are abandoned and fields that where like people started cultivating again. Okay, so now just the operational uses. The first objective with this type of analysis really is the inform the food security analysis. Cadre harmonisé, IPC, depends on where you're sitting in, but basically for some hard to reach areas where there's absolutely no information, this has been really valuable. And then we've tried to propose some thresholds to facilitate the interpretation of the results, etc. But it's been consistently used in 7 countries now in the Sahel, and also now it's being implemented in Haiti. Second objective, and it's very important, is the geo-targeting. So it's used to inform like the response planning or early warning for for geographical targeting, basically, not just WFP's response, but the rest of partners, like your humanitarian partners, and also like government, and and the third, I wouldn't say objective, but it's also very useful for advocacy, usually in areas where you might not have much to show because of data gaps. So it's also very useful for that. Okay, and then this is my last slide. I wanted just to highlight some of the opportunities that I think this kind of project presents. Okay, it's extending the support to more countries that may face the same access constraints, or try to apply it and adapt it to other contexts. Trying to, from Google Earth Engine, like this is in progress, but like write a Python code, so it would be usable from QGIS, which should be available soon. And experimenting too with machine learning. We've been asked a lot how to, like this could just be something we press a button on and we have the results of the hectares lost, but it's not really operational yet, because there's a lot of heterogeneity from one place to the next. Like even within one same region, it's very hard to have one script that works for all. So also because it's the needed the information is needed very quickly, and usually having to kind of manually clean the results and adapt, and is actually taking much longer than manually doing the analysis on the go. And synergy with regional local initiatives for early detection of crises is very important. And also, obviously, I mentioned it, but capacity strengthening activities to ensure appropriation by national and government state actors, developing open source toolkits, etc. This is already, it has been in progress and working in a few countries, but this is something to expand always. So this is it for me. Thank you so much for your attention, and if you have questions, I think now probably can go with the questions.
Thank you. Thank you so much, Laure, for an excellent presentation. So with that, we will now open up the floor for questions and answers. Please introduce yourself, and if you're directing your questions to a specific presenter, please indicate. So I see somewhere at the back. Is there a microphone?
Hi, I'm Sean Luna McAdams from the Center for Effective Global Action. The first thing is, Sarah, I have a cough drop. Would you like one? You have? Great. Awesome. My question is, I have two questions. The first question is about the data collection. How do you guys think about building in-house capacity for georeferencing your own data collection versus hiring a survey firm or a third party to do that for you? And the other question is, what's your experience sort of translating this analysis to someone that's going to use it to make a decision, and sort of what are the challenges there in communicating effectively?
Hey, I don't know who that question was directed to, but I'll probably go ahead and explain the way we do it at IFAD. So we don't actually do the data collection ourselves. So we use third-party data collection firms or entities. But at the same time, the project teams, as Oliver indicated for us, we don't implement the projects. These are usually implemented by a unit in the government or an entity in the country. They have a monitoring and evaluation team that also usually hires a third party to collect the georeference, to georeference the sites. That's how we approach it. I don't know.
So at WFP, we operate a little bit differently. So it depends on the context, it depends on the country office and whether there's capacity. So in some cases, our country office colleagues, they will have field missions and they'll go and collect the coordinates. In other cases, we work with cooperating partners who also do it. And again, yeah, the capacity, it varies from one country to another. So we're actually looking to invest in some capacity development around field data collection for coordinates, but then also, as I mentioned before, for our soil indicator initiative for soil samples as well, and marrying those two initiatives together.
I don't know if anybody else wants to answer.
Yeah. I also
some more questions. Okay.
Yeah.
Yes, the question on translating I guess the communication. Well, essentially, I mean, for us, it's still more of a new area, really, and we've mostly been working on essentially producing different kinds of knowledge products, but also engaging with the governments, particularly governments, because most of our programs are implemented through governments, and sharing those results as part of our policy engagement. So essentially just informing the different stakeholders in the country in terms of how that information can be used for future investments or designs of new projects. I don't know, do you want to? No? Okay. Yeah.
So in WFP and specifically in AIMS, this has been quite a challenge because you take this complex Earth observation data and you're talking to, very skilled people in their area, but they have no idea what Earth observation is. So we have gone through quite a long process of learning some lessons. So we've broken it down into different ways of communicating. So the first is we have an executive summary, no imagery, just charts. That's, for senior management. Then we have a slightly longer report, and then there's an annex with more details. Then we have a technical document, and then we have our academic papers that have been published. So the intention is to kind of serve all audiences, but we have definitely learned a lesson. And for those decision makers, of our colleagues in the field, it just has to be something very simple and not even necessarily a map or an image. They need a number, and you might need to know where to go.
Yeah, I have one question. That I'm Manjula from Sri Lanka. That is question for the Athur or Mundy. That you have selected for Sri Lanka for that small scale the tea and rubber plantation mapping, no? That who that selected for that particular district, that Monragal and Ampara, that's selected by you or that?
Yes, so that project, the STAR project, the tea and rubber, project, how do you say, it's about to close, and it was the tea authorities and the rubber authorities who have selected the smallholders who have been supported.
Then more you are more focusing on the small scale tea and rubber industry, no?
So wait.
A small scale one?
Yes, yes, all small scale. The plots are
Small.
about a hectare large, and it was accompanied by other investments as well. So small
Alright.
processing facilities, a linkage to the rubber processing facilities and so on.
Ah.
Even road development, so like not big, like small
yeah.
small roads and so on.
Okay, okay. Thank you very much.
If you want to talk more about it, we can chat.
Yeah.
Been there in March.
I can't remember who raised their hand first. I'll probably go ladies first. Maybe, yes, please, Lydian.
Thank you. I was excited to hear, I think it's you, Athur, or your colleague say that you're now doing systematic integration of GIS in the IFAD M&E systems, which is a good thing. But when you fund projects and programs and governments implement them, do you require them to have a component of impact evaluation? And I'm asking this, or impact assessment. I'm asking this because it becomes very difficult to do impact evaluation for government programs because they view a third party as policing them, so to speak. So getting the data becomes hard. And you indicated that you normally have policy engagement with them even to see how they can use the data. But at the beginning, do you encourage them? Do you mandate that they do collect data, or they organize themselves for impact evaluation?
Maybe that's a question for me. That's actually an interesting one, because the way we operate, I mean, every country is a sovereign state. So we cannot mandate a government to do something. But what we do have is in our financing agreements, we have in the agreement, there is an agreement that they will report on at least on the results of the project, and that IFAD's role is to support the process of reporting. A separate part of that is that because we have had to commit to the member states, the governments themselves, to report on our impact assessments. So they are aware that if their project is selected randomly, then that impact assessment has to be done. And it's all done through, mostly through ministries of agriculture, but also in cooperation with ministries of finance, because the financing agreement is with the ministries of finance. So it is such that it's, at least because it's a partnership between a UN agency and the government, and they're borrowing the financing from IFAD. It is in the financing agreement. So that's what makes it easier. For their own projects, we also try to encourage them to do the impact assessments or think about evaluation at the beginning of their projects. But it's not every country that will do this. So as they're sovereign, so they can decide how they want to run their own projects. Yes, you raised your hand.
Thank you. And thanks a lot for these very exciting presentations, a lot of awesome input. I have a little bit technical questions around the counterfactual, and Athur, first to you and then to Sarah. You explained at the beginning very quickly on the ex post evaluations at IFAD. So can you expand a little bit more how you identify a comparison group counterfactual? Are you only using geo-referenced images? Are you also ground truthing information? Are you triangulating your data? Are you looking at anthropogenic effects? Like how are you ensuring balance? And to Sarah, related in a way, but I've seen you look into the neighboring areas, but sometimes don't you fear that your control or your comparison group is then kind of skewed? Imagine an irrigation perimeter most likely is selected because it's the best location. So looking outside could bring in bias, example, very far, very distant plots from a village, so not convenient to cultivate and so on. So wandering around the counterfactual.
Great. I don't know. You want to go first?
Okay, sure. Well, so actually, one of the first iterations of the methodology, we actually looked at the full landscape around, and factored in locations, control sites that were further away. So it's a good point that you have, but then we had to balance up, locality and proximity to the intervention site and keeping the other conditions similar. So it's a balance, but we are able to look at both. We can focus in just in the buffer zone, and we can also look outside as well.
Yeah, so from our side for IFAD's impact assessments, just to note that we do use multiple levels of data. So before we actually sample the locations, so initially we start off with the full sampling frame of our beneficiaries, right, which we get from the projects, the M&E data that Oliver referred to. And then we essentially, the first part of that is randomly selecting the villages. Usually we're going at village level because most of our interventions, they select villages, and then within the villages, they select households. So by randomly selecting villages in the treated areas, we believe that we know that is representative of our beneficiaries in general, because it's random selection. Then, based on the randomly selected villages, we now look for comparable villages that are comparable to the selected, randomly selected ones, right? So the matching is at that level is ex ante before we go for the data collection. It's being done at village level. Whatever administrative data we can get from, National Institutes of Statistics, for example, or other sources, whether it is, for example, the World Park data, infrastructure information that we can get from satellite imagery. We try to mirror that as much as possible. So I showed you the example of Papua New Guinea, where we've tried to do this, also trying to automate this through a random forest selection process. Then we go in and do the surveys. So normally for our treated areas, we know the beneficiaries because we have the information. The challenge is usually the control group. And so depending on whether there is a registry of the people in those villages, or if not, then we can resort to, for example, the buildings, like the selection we did in the Philippines, where we identify buildings and then go in with the enumerators to try and verify first, is it a household? Is it maybe it's just another a building that's not a household? And then actually try to check the characteristics of those households to see if they certain criteria match the selection criteria into the project at the baseline. Following that step, if they pass that test, then we go ahead and do an interview. So after we've done the interview, we now have data, household level data, for both the treated and control. And then we do a second round of matching in our propensity score matching techniques, which means we have matched ex ante at village level using geospatial and administrative data. We also, by the way, during the household survey data, we collect community level data. So if there are other projects there, like in the case of the Philippines, there were other projects like the World Bank project or Asian Development Bank projects that had been implemented. So we have to control for that as well. So we try as much as, but I know I'm getting a lot into the details, but the point is that we try as much as possible to check. And then we obviously look at the balance in our data, and in most cases it's pretty good. So for whatever is observable, I think we're safe. I think the biggest issue is unobservables, right? And the fact that in many cases, we don't always have a baseline. In some cases we do, which means then we have a panel, like some projects in Malawi, Tajikistan, we had a panel, 3 rounds of surveys. So that was really great. Yeah, thanks. I don't know if, I think there was a question from, yes, Chris.
Yeah, thanks. Actually, a lot of the things I wanted to ask have already been asked and answered. So I have just one more. I guess it was Sarah who showed that you check, your sites of interest, also using very high resolution imagery. And you illustrated that you check it and then monitor it over time. So I'm curious there, because with very high resolution imagery, especially in rural areas, you will not have the chance to regularly monitor it over time because you simply don't have imagery coming in. So how are you doing that, or what were you referring to?
So we're quite lucky that we do have access to quite a full archive of high resolution imagery. It's a WFP, but then we also task the imagery. So when it's not available, the time that we need it, then we task it through various providers. So that ensures that we have the correct cadence of monitoring.
Very nice. So you have framework agreements with, say, Airbus Maxa to do the tasking, or how? I'm quite interested in that setup.
Yes, yeah, we do, yeah.
Thanks.
Oliver, you can go ahead.
I've got a question for Sarah. What is what is the toughest asset to monitor?
I wouldn't say the toughest asset, but the toughest context is somewhere like DRC or Myanmar to monitor any asset because it's already so high in vegetation, high cloud cover. It can be quite tricky to find it. And also those assets where we've been provided the wrong coordinates are also tricky.
Any other questions? I guess we're coming to a close, but maybe just a quick one for Laure online. Just if you could maybe say something on the data that you referred to on conflict, particularly in Haiti, because I saw you're using ACLED, but you're also using other sources. Just wondering any challenges to actually verify conflict data, because that's something we've struggled with at IFAD.
Okay, yeah. Can you hear me, right? Yeah, so in Haiti, we've been, in addition to ACLED, we had some, it's mostly fields like data from the field, information we get from country sub-offices, like the WFP sub-offices, or agents that work for national institutes and are based in regions. And then from this, we kind of translate into GIS information. So, yeah,
Great.
It's very challenging.
Thanks so much. And with that, I think we can close this session. Thank you so much for your attention and participation. Thank you.
Thank you.